Hello, everyone. Good evening. Sorry for the delay. Okay, I think we can start. Okay, so yesterday we started discussing arrays, right? So let's continue from there. Let's start by discussing arrays. What's more is there in arrays, right? What else we can okay. First of all, before like going more into depth of arrays, we will try out the questions that's there. So did you try out the questions of arrays? Yes, no.
Yes, sir. Sir, you were not audible. Sorry.
I was not audible.
Yeah, maybe my bad.
Yeah. Can others confirm? Was like, is it clear? Is the voice? Yeah, audible. Okay, thank you. Okay. Explain the sum of array from a yes. I'll explain the sum and subtraction. Right. Those two I'll explain. Apart from that, did you all try right in overall got the idea of arrays? Other than sum except self. Did you all complete the subtraction question? Is that done? And without using recursion, right? I'm talking without using recursion because we have not done recursion till now. So I expect that will be done without recursion for now, at least. Okay, so interesting. Then that's a very good start. So let's start by discussing on these questions. So let's take some time today to discuss these questions first, complete them, and then we can jump back to arrays and we can learn a few more concepts, right? Okay. Second largest one is a very interesting question. So I'll give you some idea about it. It's actually not what it looks like over here. Okay. Firstly, on the functions question, all the questions are done, right? Did you all complete this question over here, which is to binary decimal to binary conversion? Is this done?
Yes, sir.
Yes. Anyone? No doubts over here? Anyone having doubts on this question or any question in functions? All done. Okay. No doubts. No doubts. Binary decimal. Okay, chalo. Let me discuss this one. Not just this question, but the concept of entire number system that's there. Okay. Okay. So see, I'll explain this question. I'll come back to this, but let me give you some idea about what number system is in general or what a number system is. Okay. So why is it? What is Chrome is also behaving very weird. Doesn't work well. So I'll give you some idea about number system that's there. Okay, so till now we use number system like we have numbers like 0, 1, 2, 10, 20, 100, 1000, 10,000 and so on, right? So what is this number system that we are used to of using, that this which contains numbers like this? So right, so which contains number like this. So what is this number system? So this number system is known as decimal number system. Okay, that we use that we are used to of using, right? That we use in our day-to-day life. For example, all the bills that you see, any prices that you see, any numbers that you see written anywhere, you assume that this is there in this number system, right? But who created this, right? Why do we have only 10 digits in the number system, right? Why cannot be 11 digits? Why cannot be why there are only 10 digits, 0 to 9? Why can't be there be 15 digits? Let's say I create another digit like this, which is let's say 11, 11th digit, right? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have one more digit. Let's say we create one more digit which looks like this, and this is the 12th digit, or something like this, which is the 13th digit, or something like that. Okay, so we could have created so many digits, right? Now we stick to this, right? We stick to this system, which is known as decimal number system, which we also call as base 10 number system. Okay, what is base 10 number system? That means there are 10 digits in this number system. Okay, there are 10 digits in the number system, and those are 0 to 9. Okay. Okay. So the number system that we use has 10 digits. Now, can we create other number systems where we have 5 digits, 7 digits, 12 digits, 15 digits, 20 digits, or what is the number system that computer uses? Does it actually use this number system?
No,
But-
sir, binary it uses.
It uses binary number system. Now, why binary? Because it understands only 2 digits, that is 0 and 1. So the number system that computer uses is binary. The number system that we use is known as decimal. Is there any other? So there are two other common number systems that are used. One is known as octal, which is base 8,
And
and
hexadecimal,
hexadecimal, yes,
16, base 16.
which is base 16. Right. So there are these many numbers, like there are altogether this 4 number systems. Can we create others? Yes, we can create base 12 number system, we can create base 14, we can create base 9, we can create base 7, we can create number systems of any given base. Okay. Now, how do we do this? How do we create? Okay, so I'll give you an example by converting it into something such a way that understand. What if we what if computer program in such a way that it understand decimal? No, computer fundamentally cannot understand any other number system apart from binary, right? Because it only understands 2 digits, that is 0 and 1.
On
So-
and off.
Fundamentally cannot understand. We can create our own number systems. Where is this number system used? So for example, let's say we have hexadecimal number system, where it is used, where it can be used. So hexadecimal number system is like a base 16, right? So this is used in encoding of things. This is used in like hardware programming, right? Where we want to type less number of information and still we can pass more number of information to the system. So there we use hexadecimal number system. Okay. So there are different uses of these, right? In encoding, in picture encoding, in like hardware programming, or in creating micro hardwares. So those kind of places we use it. Right, we like rarely use it in actual software, to be honest. But yeah, there might be places where you might need to interact with them, so you need to know them. Okay, so I'll give you an idea of one, and it's very simple to understand. It is like super easy. So let's say we have 121, and it is written as base 10. Because so base 10 means simply that it is a decimal number. 121 base 10 is a decimal number. Now I have to convert the same 121 into binary number, which is base 2. Okay, I have to convert this into a binary number base 2. So how can we do it? We can simply divide this 121 by 2. We'll get 6, 0. 1 will be the remainder, right? 60 is 120 and 1 is the remainder. Now again we divide by 2, it gets 30, 0 is the remainder. Then we divide by 2, we get 15, we have another 0 as remainder. We divide by 2, we get 7. We have 1 as remainder. We divide by 2, we get 3, we have 1 as remainder. We divide by 2, we get 1 and 1 is the remainder. And then we write from bottom to top, this is our binary representation. So we have 1, 1, 1, 1, 0, 0, 1. So this is the binary representation of 121. Can we find it in some other base? Yes, we can. So let's say we want to find the 121 in octal numbers. We'll simply divide it. Instead of dividing it by 2, we'll divide it by 8. So 8 1 ja 8, 40, 41. 8 5 ja 40. We have 1 as remainder. 8 1 8, 8 7 is the remainder. So 171. The same 121 is represented as 171 base 8. They all mean the same value. In decimal number system that we understand is 121, but in other number systems it would be written like this. Okay. So the digits that is present in octal number system, which is base 8, the digits here are 0 to 7. So any number will have digits 0 to 7. In base 2 number system, the digits that will be there is only 0 and 1. Okay. How can we do it into base 16? So base 16 number system represents it. Okay. Now this base 16 number system actually has 16 digits. So the first 10 digits are 0 to 9. And then the 10th digit is A, then we have B, then we have C, then D, E, and F. Okay. So this represents 10, 11, 12, 13, 14, 15. So total number of digits is 16, 0 to 15. Okay. So 0 to 15, the total number of digits is 16. And the digits after 9 are represented by A, B, C, D, E, F. Okay. So now let's look at here. So it is 112, right? So it's 7 ja 112, and we have 9 as remainder, I guess. 9 as remainder. So it is 79 to the power to the base 16. Okay, which is like having digits 0 to F. Okay, so this is a base 16 representation of any number. But simply we have to divide it by that particular base, whichever base you want to convert, and this is just for decimal to any base conversion. Okay, So if you have decimal and you want to convert it to any base, right? Decimal to any base, you just need to divide that number with that particular base, right? So for example, you have to convert it into binary, divide it by 2, and whatever is the remainders that you keep on getting, that just write it from bottom to top. That is your binary number. If you want to convert it into like octal, which is base 8, just divide it by 8. If you want to convert it into hexadecimal, divide by that particular is 16. Okay. Now for any, so for example, any base system, for example, 7, 8, 9, these are like less than 10 digits, right? So you can simply have 0 to 7, 0 to 6, 0 to 9 digits. But what if you have base 16, base 15? So then you will have alphabets as your digits. Okay, so if you have base 15, base 16, base 20, so the first 10 digits are 0 to 9, then you'll have A, B, C, D, E, F, and so on. What if after 26 alphabets ends? Then you might use some special characters, but okay, till then you can use this as digits. These are digits in the number system. Okay, understood? Yes, no, clear? Got some idea how you can convert basically one into this. Diamond question also will complete this. Yeah, today we'll do basically questions only discuss array questions, complete the previous questions that we have left off. So all the questions we'll discuss. Okay. Okay. Now, okay, so we converted every number from like, let me write it clearly at the top. So it is 121 base 10. It is represented as 1111001 as base 2. Okay. And then we represent the same thing as 171 base 8, or the same thing as 79 base 16. Okay. Now this is easy. What if you are just given the reverse task? You are given any number in any number system and you are asked to convert it into its corresponding decimal representation. So what we need to do? So in order to convert from decimal to any, we divided. Now what is the like just opposite of division? We need to multiply, right? So when we want to convert from decimal to any number system, we'll simply divide. And when we want to convert from any number system to decimal, we can simply multiply. Okay, so let's check the same thing on the numbers that we converted. Right, so we just converted these numbers into this, right? So we can check the same thing. So for example, let's say this was a binary representation. We converted it into decimal, right? So sorry, this was decimal and we converted it into binary. This is how binary looks like. Now, how can we convert this binary back into this decimal? So let's say we are given this as binary number and we have to convert it into a decimal number. So we'll take the powers from here 0, 1, 2, 3, 4, 5, 6. Okay. So these are the powers and we just need to multiply them. So 1 into 2 to the power 6. So this is 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3. Okay. Plus this is 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Okay. Now let's check what is the number we are getting. So 2 to the power 6 is 64. 2 to the power 5 is 32. Plus 2 to the power 4 is 16. 2 to the power 3 is 8. Then this is 0. 0 multiplied anything. 0 multiplied anything is 0. And the last one is 1 into 1, which is 1. Okay. So it is 64 plus 16, which is 80. 80 plus 40, 120. And this is 121. So you get the 121 as base 2. See? So from using the binary number, we can convert it into decimal. Using the decimal number, we can convert it into binary. Okay. Now, how can you convert 171 into this binary number? Same logic. 171, we use the base 8. So there 171 is having a base 8, right? So we'll have 0, 1, 2. Okay. And we'll multiply this with 1 into 8 to the power 2. Here the base was 8. So the multiplication base is also going to be 8. Here the base was 2. So multiplication base is also going to be 2. Okay. This is 7 into 8 to the power 1 and 1 into 8 to the power 0. So 8 square is 64 plus 7 into 8, 56 plus 1. So it is 121 again. Okay. and this is base 10. And similarly, you can convert 79 as well. So let me do quickly over here. So this is 0, 1. So 7 into 16 to the power 1 plus 9 into 16 to the power 0. So 7 into 16 is 112 plus 9, which is 121. Okay. Understood? So basically, in order to convert from decimal to any number system, you need to do division. In order to convert from any other number system to decimal, you just need to do multiplication. Right now, this is valid not just for binary to decimal. This holds true for any base number system, be it binary, which is base 2, be it octal, which is base 8, be it hexadecimal, which is base 16, or be it some other number system with any other base. Right? Let's say in a question you got, like, let's say we are going to create a base 14 number system. Right, and the digits in the number system are 0 to 9, and then we have A, B, C, D. So this is a base 14 number system. Okay, now here you are given a binary number, you have to convert it into this particular number system. Or let's say you are given a number in this particular number system, convert it into decimal or something like that. Right, so you just need to follow this rule. Okay, acha. Understood this part? How can you convert decimal to any number system or any number system to decimal? Understood this? Decimal to any to decimal. Anyone, any doubts? (29H) to decimal. 29H does not exist in hexa, right? So this would be there in some other number system. So H would be A, B, C, D, E, F, G, H. H is 8. So 29, actually 20. This is A. Okay. So this you can multiply, right? 0, 1, 2. So this is 2 into 16 to the power 2 plus 9 into 16 to the power 1 plus A is 10. So 10 into 16 to the power 0. So while multiplication, while expanding this digit, you can use it as 10, right? So this is nothing but the actual 10, but we are representing it as A. Okay. Okay. Now, I got the question. Okay, understood this part. Now the last question here is, what if we get some other intermediate conversion like octal to binary, or hexadecimal to octal, or hexadecimal to binary, right? How will we do this? See, there are direct ways as well. You can do that, but that is very complicated to remember. Okay. A को 10 multiply करना है, देखो 29 A में you can take this as 0, 1, 2. So this is 2 into 16 square plus 9 into 16 to the power 1 plus 10 into 16 to the power 0. Okay. So this A is used as 10 in the multiplication. It will be used as 10. Okay. Now, actually, there are direct ways to do this. You don't need to do them directly, right? You don't need to do them directly. The easiest trick you can follow is octal. You can convert it into decimal, and from decimal you convert it into binary. Just use the decimal in between for this conversion. So that will make everything easy, right? Hexadecimal to decimal, that you know, that is easy, and decimal to octal you can do, right? So that will be more easier than doing that direct conversion. There are ways to do this direct conversions, and that are like I'll say that would become a little bit complicated for understanding so many number systems, right? So best one is remember just to decimal to any and any to decimal, which you are used to, right? All the calculations and everything is also there in also happens similar to decimal number system. So there is nothing different, right? You don't have to understand anything new, and you can just follow this, right? The time wise also both of the logic is going to take same time if you write it in code as well. Okay. Understood? Clear? Yes, no? Okay. So this is it about number systems, right? That you need to know. And this is it number systems about in computers. So in the world of computers, in the world of programming, we use different number systems, right? Different places, different kind of number systems might be used, right? somewhere it, okay, I'll give you one practical example that you will be able to understand this. So let's say we have this number which is 2a 8b, okay, base 16. Just try to find out the value of this. Just tell me what is this. Anyone having a calculator, can you calculate this for me? 10 into 16 square plus 8 into 16 to the power 1 plus b is 11 into 16 to the power 0. So this is 2 into 16 cube plus 10 into 16 square plus 8 into 16, 8, 16, 96. This is 96 plus this is 11. Okay. Anyone can do this calculation for me? 16 square is 256. No. 16 square is something different. So I'll wait. Someone tell me in chat. So this is the answer, right? So we have 10891, right? So this is the number that 85859, 891. I guess 859. 859 it is. Just check once. Yeah, 859. Yes. So this is the number that we that we got. Now see, so here in the actual decimal number, it takes 5 digits to represent this number, right? But in the hexadecimal format, we represented it using 4 digits, right? In the actual number, we need 5 digits to represent it. Now, same thing like if we have an even larger number, if you take even a larger number for this hexadecimal, you will be able to get this easy. Okay, so what is this ABC concept? See, so basically in hexadecimal number system, you have 16 digits. Okay, so 16 digits में first 10 digits are 0 to 9. ये तो है fixed first 10 digits 0 to 9. What is going to be your 11th, 12th, 13th digit? So your 10th, 11th, 12th, 13th digit, what is going to be that? So this is your 11th digit, this is 12, this is 13, this is 14, this is 15, this is 16. It is alphabets. Okay. So after your first 10 digits, then your alphabets start, right? And then you have alphabets. So this is represent the number 10, this is 11, this is 12, this is 13, this is 14, this is 15, right? So base 16 numbers would have 16 digits, that is 0 to 15, and these are the 16 digits, 0 to 9 from the normal number system, and then you have A, B, C, D, E, F. Understood? Conversion and all makes the system slow. So actually, see, whenever you are using decimal number system as well, the conversion is anyways happening, right? So these conversions are faster. These conversions are very, very fast, right? This is not slow. These conversions are very fast, right? From decimal to binary, because our machine doesn't understand decimal numbers. We use decimal numbers. So every time anywhere we are writing, right, A equals to 5 plus 10, right? So let's say when we write int A is equals to 5 plus 10, is this addition actually happening in the 5 plus 10? Machine doesn't know what 5 is, what 10 is. It converts it into binary, it adds it, and then reconverts the result back into decimal that it shows to us. So conversion is anyways happening, right? Whether it be conversion from decimal to binary, or this like hexadecimal to binary, or octal to binary, and so on. Okay. Yes, so we use these number systems. Yes, there are usage. For example, hexadecimal is used in image encoding, hardware encoding, right? So hexadecimal is there is even in microprocessors programming. So there it is used, right? So there is your applications of them mostly in hardware programming and microprocessor related kind of thing. In actual software, we use it very less, to be honest. Right? Actual software, the application is very less. But at times, sometimes you might get this like something where you would get to see this, right? Not very common, but there are places where it is used. Okay. So that's why I just need to know that there is something like this, that there are different systems that exist and we can use them. What's the important of this? So see, the only thing is, so we initially started by having only two systems. We understand decimal, and then we understood, okay, binary is something which machine understand, right? So we had only two systems. Decimal is ours, and binary was machine, right? Then few people felt ki we need some other number systems, right? So they created octal, hexadecimal, right? So yeah, no one prefers them using a lot, but it is used in a lot of places. So for example, let's say I want to create a calculator kind of keyboard, right? Where there can be like only 4 buttons. Okay, there can be only 4 buttons, but you should be able to perform the addition or all the different kind of additions that you want, right? So how can you create such kind of calculator or something? So you can create it if you have a base 4 number system. Okay. If you use a base 4 number system, you'll still be able to get the addition of all the numbers. But if you try to use a base 10, you cannot create that calculator using 4 digits, right? So in such places, this kind of things is used. Okay. So I'll give you one more example. Okay, think it like this. So you all have used, right, your television remotes, right? So television remotes has a given number of fixed keys. Let's say there are 20 keys. Okay. So either we can give them a number in decimal number system 1, 2, 3, 4. So whenever you press a key, there is some information that is passed to the television that the user has pressed the key this. The user has pressed the key number this. The user has pressed key number this. Either that can be one way, or they can give one unique number to each of this. So let's say there are 20 numbers, so they will create a base 20 number system. They'll use a base 20 number system, and they will pass that number to the system, right? Now that makes the processing little bit faster, because it has to pass only one digit instead of passing multiple digits, right? So when you press, like, let's say there is a 20 digits, instead of passing 20, it can pass just a simple character like C, whatever is this 20th character, J or something. Okay, so it will pass that character instead of passing this. Okay, now this might look like a very small difference. We can pass two characters, but why we need to pass one single character? But actually, this might be a lot optimized, right? The television would be actually faster if you pass one character instead of passing two. So those kind of things, hardware places it is used a lot. Actual software programming, we use it lesser. Okay. There are hex codes assigned with a lot of places. So hex codes are something which we use, and that is like hexadecimal codes. So hex codes are present for colors that we use. So the colors that we use online are having a code to it. Now that is given in hexadecimal coding system. So that uses hexadecimal number system instead of the normal number. Okay. Okay. Understood. Hope this gives you some idea about where it is used. Sure. Okay. So now let's come back to this question. So this was a very basic idea of like the entire number system that you can get, right? So here the simple question is basically you're given a binary number and you have to convert it into decimal. You have just to write this function, and all the other logic is written, right? So it will take multiple, it will run the loop for the multiple times. It will take multiple string inputs, and for each string input you have to give a decimal number. Okay. Now how do we do binary to decimal conversion? Multiplication, right? Decimal to binary is division, so binary to decimal is multiplication. Let's say we have a result which is initially 0. Okay, we'll add it, we'll find out the result. What we can do is we have a string, right? There was only one thing that you had to figure out, how will you go through each character in the string. That's it. Okay. So we have a string, we just had to figure out how we go through each character. We already know how can we get one character of the string. So for example, if I want to get a character of the string is, we can use caret, right? So using this, we can get a character at any particular index, 0, 1, 2, we can get that, right? Achha. So there was only one missing piece that you have to figure out, how can we get the number of characters in the string so that we can traverse it. So that you can do it using string.length. Okay. Then, so we can start from 0, we can go to n less than n, because the first character, so index is always going to be 0 to n minus 1. Same thing that we understood in this. In case of array, same thing we understood in case of arrays, right? So now the character that we'll get is s dot caret I, which is the ith character. Okay. Now we'll get the ith character, and this would be a character format, right? So the 1, 0, whatever we would get, this is a character. This is not an actual number, right? What is this? If I store it in integer, will we get the like value 1, 0 or something, or do we need to do something? Did I earlier tell you something about this? Key 1 as a character is we have to subtract 48. Yes. 1 as a character has a ASCII value 48, right? We can iterate through a string like an array in Java, right? So we can iterate through a string character by character. So we already have a function that gives me each character. We just needed to figure out this. That if we can find out the length of the string, we can go through each characters in the string. Now, once we go to the character, we got the character. Now we got, let's say 1 as a character. Let's say the number that we want to convert to from binary to decimal is 101. So we got 1 as a character. Okay, 1 is a character. Now we have to convert this into, so 1 is a character. So if you store this character into integer, you are going to get 48. Okay. If you try to store this 1 as a character into integer, the value that you are going to get is 48. Same ASCII concept, right? I told you, right, in the ASCII concept, if you store a digit which is stored in a character into an integer variable, you are going to get its ASCII value. Now, in order to convert it into the digit, in order to convert it into the number, you need to subtract 48, or if you forgot this value, right? So 1 is 49, right? 1 is 49, but you need to subtract the ASCII value of 0, right? So that you get to 1. We want 1 as the number. We don't want 0, right? So if you subtract 49, we are going to get 0. Right? So for example, let me explain this again. So let's say if I write this, which is 1, and I print this. So this would print 48. Sorry, 49. So 1 would print 49. Now if I want 1 as a number, so I need to subtract 48 or the ASCII value of whatever 0 is. So whatever is the ASCII value of 0, that I need to subtract. So I get the ASCII, I get the actual digit 1. Okay. So if you remember this, you can subtract 48, or in case you forgot, so you can subtract 0. Both of them would give the same result. Now, once we got 1 as a character, we just need to multiply it with the power of something. So we need to find out the power. So if I start with 0, 1, so the highest power is going to be n minus 1, right? So in an n length number, we are starting with 0. So the highest power is going to be less than 1 length. So for example, let's take this scenario, right? So here there are three digits, right? So let me take a larger number. So how many digits? 5 digits. So if I give the powers as 0, 1, 2, 3, 4, what is the highest power that we are going to get? Is 4. What is this? This is n minus 1. So whatever is the total length, that is n minus 1. So that is the highest power that you are going to get. And that is going to be on the first character. Okay. And now in order to find this result, we can do result is equals to result plus whatever the existing result is. The A that we got into 2 to the power this, right? So 2 to the power something, how we can find? We can use math function, math.pow, right? And we can do 2 comma whatever is the power, right? After doing this, we can decrease the power by 1, done. And at the end, we can return this result. We'll do it for each characters and we'll find out the result. So I'll do a dry run quickly to explain you this. Let's check this result once, whether we are getting correct result or not. Incompatible types. Oh. So power returns your decimal, you have to convert it into integer. No need to iterate. So if you iterate from the string backwards, you can take the power from 0. If you iterate from the string forward, we can start with the power n minus 1. Okay, you can take from 0 and you can see addition from forward or backward, both would work in the same way, right? Either you add from any direction. So I've taken power from n minus 1. If you take power from 0 and you increase it, you can got it. You can iterate from backwards. Okay. So let me do a dry run. So let's take this example. For instance, 111. Okay, this number. So we have given the power here is 0, 1, 2. Okay. So this should be the scenario. So we took n is equals to s dot length, which is 3. P is equals to n minus 1, which is 2. Okay. Now what we are doing over here is we are checking is it less than, so we started with I equals to 0. We are finding out the character at index 0. So what is the character at index 0? This particular character. We got 1 as a character. Then we subtracted 0 from it. So 1 minus 0, which is 1. Okay. So you got 1 as a number now. Now what we want to do? We want to do result is equal to result plus, which is 0 plus 1 into mat.pow 2 comma p. So 2 to the power p, which is 2. Okay. So you got 0 plus 2 square, which is 4, which is 4. Okay. First iteration, we decreased power decreased by 1, so it became 1. Okay. And then we went to the next iteration. So for I equals to 1, we found out the next number, which is again 1. So 1 minus 0 is again 1. So now we have 4. So we do 4 plus 1 into 2 to the power. Now power is 1, right? So power has decreased to 1. So 2 to the power 1. It is 4 plus 2, which is 6. Okay. Now again we decrease after doing this calculation, storing the result, we decrease the power by 1. So power becomes 0. Now next iteration for I equals to 2, what we do is again find out the character, which is 1. 1 minus 0, again we get 1 as a 1 in A. We do 6 plus current value of result is 6 plus 1 into dot power 2 comma power is 0. Okay, so 6 plus 1 into 1, 2 to the power 0 is 1. So this is 7. So we got the result as 7, and we are printing 7, which is correct result. Right? And validate this. If you try to convert 7 into binary, you'll get 1, 1, 1. So 2 3s are 6, 1 is the remainder, 2 1s are 2, and 1 is the remainder. So see, 1 1 1 is the binary representation of 7. Okay, understood? Yes, I know I went a little bit fast today.
Sir,
Yeah.
I'm not getting this int a equals to c minus 0. Why we have done this?
Okay. So let's say I get a simple character which is 1. Okay. So let's say we pick one character from the string, whatever it is stored. So let's submit this and then I'll explain this in GDB. Okay. Just a second. Okay, done. So let's come back over here. So let's say that we have a string which looks like this, which is having 1 1 1 or 1 0 1, okay, something like this. Now let's say I pick one character and I store it directly into integer caret 0. What is caret 0? Caret 0 is 1. 1 as a character. String gives 1 as a character. Each part of the string is a character. It is nothing. It is not a number, even though it looks like a digit. It is actually a character. Okay. So now if you print this A, you're not going to see this as 1 as a number. You're going to see 49. Now, why is this printing 49? From where 49 is coming? So it is the ASCII value of 1 as a character. So ASCII value of 1 as a character is 49, right? So ASCII value of 0 is 48, 1 is 49, 2 is 50, and this is in order, right? So 0 to at 9, the ASCII value is 48 to 57. Okay. So that's why for 1 you are getting this. Now, how can we convert this into actual number 1, actual digit 1? So you need to subtract 48. Either you subtract 48, or let's say in case you forgot this, what's the ASCII value of 0? So you just can subtract 0. Okay. So this is going to give you 1 as a number. Okay. Got it. How to convert decimal to binary? Okay. So decimal to binary, I'll write that logic over here. Understood this part? Is this clear? So we did this. Just that if you have this as octal or something else, you just need to change this. If it is octal, you just need to change it to 8. There is one additional step. Just if it is hexadecimal, then you have to check if the character is A, B, C, D, E. So even you then need to convert A to 10, B to 20, B to 11, and so on. Okay. So for example, if this was hexadecimal, there was only one small change that you need to make is 8. Okay. If this was a, sorry, octal number, if this was a octal number, you can simply convert it into decimal by just changing this to 8. But if it was a hexadecimal, you can change this to 16. But there is one other change also you have to make. If this character is equals to A, then you have to assign the A value as 10. A would be 10 in that scenario, and for B it would be 11, and so on. Okay. Rest all things works the same. See, integer.parseInt works, but every time you don't need to use methods, right? There is some basic element of programming that also you need to know, right? So methods to be created, right? Method you can use anytime, methods you can use, right? Methods are, it can be used any day, but this programming big fundamentals you cannot learn every time, right? And this won't change. So there is, let's say, some place where you don't want to use method, or sometime interviewer says that don't use this method. So there goes harm. So the best suggestion I always give is, when you're learning programming, right, try to use least amount of inbuilt function, right? ParseInt, string functions, sort, everything, try to minimize the usage of them. And when you become very good, right, you will automatically like write functions, and you'll feel confident of what it is doing, right? So you will also know that function, what it is doing. So let's do one simple logic. What if we have a decimal and we have to convert to binary? Okay, so let's do this. So let's take a decimal number. Int A is equals to 19 something like, let's say 192. So till when we have to do this division? Until A is not equal to 0. Once A becomes 0, then we don't have to do anything. Okay. Let's try to store this binary into number itself. We can store it in string as well. No problem. Let's for now store it in number. I'll show you storing in string as well. Okay. So what we need to do is, there cannot be any leading zeros, doesn't mean actually anything. So if there are leading zeros, that won't mean anything. There is only one thing. Okay. Okay, so let's store it as string itself. Okay. There might be some complications of storing it in number. Of that trailing zeros, we have to handle it separately. Okay. So let's store it in this way. So let's say it is a string which is empty. Okay. Now what we need to do is, we need to firstly figure out the remainder, which is a percentage 2. So we divide it by 2. Whatever is the remainder that we got, this is the last digit in our binary representation, right? This would be the last digit. So what we can do is, we can add this, but since this is the last digit, we'll add it at the so every new digit would get added into the start. Okay, so this R that we got, we'll add it to the start, and then whatever result we already have, we'll add it at the end. Okay, system.out.println, and we can print the result. Then only thing we forgot to change was the number. The number will be A divided by 2. Okay, understood? So whatever is the remainder that we got, we added it into the start. Okay, so that we get the number in reverse. So let me show you this. Let me run this once, and then I'll explain it by using a driver. So this is the number that we got, right? 11. And how is this so many zeros? It shouldn't be these many zeros. What did we have to do? Hello, let's check. Okay, might be. Chalo, 192. It could be. So let's try to check what is the actual representation. 192. Okay, let me validate whether it is correct or not. I guess it is correct. Reverse plus R will give the reverse order, right? Now it's correct. See, it's correct. 11, 15 is 111. Okay, see, let me explain you this. Why this color? Okay, see. So for 15, we divided by 2. So 2 7 are 14, 1 is remainder, 2 3 are 6, 1 is remainder, 2 1 are 2, 1 is remainder. Right. So we write it from bottom to top, right? So the first division will give you the last digit. The first division gives you the last digit, right? So we have to put this first division as a last digit. Now check what we are doing. So we firstly took 15, but we check 15 not equals to 0, we divided it by 2. and we got the remainder. So what's the remainder we are going to get? R we got as 1. What we did 1 plus result. So we added 1 and then the result at the end. So whatever was the current result which was empty, so we added it at the end and it became 1. Now look at the next iteration what we are doing. Next, so we divided a by 2, it became 7. So let's take some other number, for example, right? So we have some zeros in between at least. So let's take 12. So we have a combination of zeros and 1. Okay, now look at this. So we have 2, 6, which is 0, 2, 3, 0, 2, 1, 1. Okay. Now look at it. So first is 2, sorry, please don't annotate. Yeah. So first is 12 not equals to 0. We come inside, we check what is the remainder. So remainder is, this gives us remainder is 0. What we are doing is we are doing 0 plus the existing string, which is empty. So we got 0 as a string. Okay. This first addition gave 0 as a string, which is stored in result. Now we divided a by 2. We divided a by 2. So a became equals to, from 12 it became 6. Next iteration, 6 is not equals to 0. We check again, find out the remainder. We again got a remainder is 0. Now we are doing 0 plus this string is getting added at the end. Okay, this string part is getting added at the end. So we got the result is 0, 0 as a string. Okay. Achha. Now, after doing this, we divide a by 2, so it becomes 3. Again, check a is not equal to 0. We find out the remainder, which is 1. 3 divided by 2 is 1. Now we add 1 plus 0, 0 as a string. So we are getting 1, 0, 0. Now look, we added 1, 0, 0. This is the string that we got, right? So we added 1 to the start. So adding this number to the start simply is reversing the order. You don't need to do result plus. If you do result plus R, you will again need to reverse it. Right? If we just write it alternatively, R plus result, the answer will automatically be in reverse order. Because every new digit you are trying to add, you are adding it in the start of the number, which is fine. So the last digit you'll add it will be the complete start. Right? Result into 10 plus R. There is one small problem here. These are going to be trailing zeros, right? So trailing zeros should be there. So now the first division will give you 0. So you have to count the trailing zeros and add them into the integer number at the end. You're getting the problem if you store this into integer. So here you'll get 0 into 10 plus R, which is 0. Then the next 0 will also give you 0 into 10 plus R, which is 0. So it is going to be 0. Then again you do 0 into 10 plus R, which is again 0. Right? So you will keep on getting zeros. So you have to count this actually trailing zeros and then you form the number. And so it becomes a little bit complicated. Storing in string removes all these problems. Okay. And you won't be even able to store the binary number actually in the number format in case for 192, this was so large number, right? So for in case of like, if you just have 200 or something, this number is going to be very large. So let's say I give it a 500 number. So this is going to be a very large number. Okay. See, so this number is just 500. So like this is already 6-7 digit number. Now beyond this, it won't be able to store. If I give it 10,000 or 20,000, then it would fail. Right? But for string case, it won't work. It would anyways still work. No matter how large number you give, that if it is stored in integer, it will be easily be able to store in string. But this thing cannot be stored into number, right? Integer. If we add string to integer, why do we get convert to a string implicitly? So string addition is implicit, right? So if you have like an integer to string addition, this is implicit conversion. So integer, any data type automatically gets converted to string. Okay. So string is like, so this happens because of string concatenation. That concept that we learned earlier, right? Which was string concatenation, where we saw that you can add any data type to string, right? You can add a, which is integer, or you can add a d, which is double, or you can add a character as well. So any data type you can add to string, that is valid. All of them will get converted to string and it will join it to form a single string, right? So this happens string concatenation, which joins it, not just actually adds it. Okay. Understood? Now got it? Yes. Clear? Okay, so this is it all about number systems. I took like around an hour, but I hope like this was interesting and you understood every bit of number system that's was required, right? So this is it about entire number system. Now you'll get conversion from one to another something. So I'll tell you like it is also used in recently like phone masking. So you see like the contact number. So for example, if you are calling a cab driver or if you are calling a delivery agent, you won't be able to see their number. Neither they will be able to see your number when you are making a call. It is a normal call, but the numbers are masked, right? The number masking also happens using this kind of number system logic, where the masking is basically converting your number to from base 10 to base 9 or base 8. So your number looks something different, right? It is 10-12 digit number, which looks a little bit different than the normal number. Okay. So there also this is used nowadays. Okay. So let's proceed to now arrays. So functions done, right? I don't expect all. Is there? Can you mark star number 2? Yes, we can actually. So that, but there is a like process that it goes through when you have to take a private number via the provider. So they do it for you, but you have to take a private number for that. Now for that you need to get a lot of clearances in order to get a private number. Okay. Acha, I forgot to inform one thing. So there is one soft skill session. Okay, I don't know. Okay, let me just check once. When it is yesterday. Okay, so there is a soft skill session that's there for all of you, right? I guess when it is you'll get to know about the dates from your batch manager. Okay, please do attend. Okay, see, I'll tell you one thing. I'll just take 2 minutes of your time. Okay. So soft skills is very important, right? Right now, you all are learning. Technical skills are important. I'll not deny that technical skills are very important. Having very good soft skills, having very good communication skills, and zero technical skills is never going to help you clear any interviews. Okay. But if you have very, very good technical skills, right? You know very good DSA, you are a very good programmer, you have built so many projects, you understand every bit of front end and back end development. But let's say you're not able to present that in interviews, then what's the use, right? You in interview have a limited time of 30 minutes or an hour, where you have to present yourself such that the interviewer will be impressed by you, right? And that can only happen if you are able to communicate well. If you are able to, whatever problem he would give you, you are able to explain him, right? Not just solve it, but also explain him that this is my approach of solving this problem. Why did you take that approach, right? What are the pros and cons? What are the alternatives that you thought of, right? So, and you have to all explain it in a very crisp manner, because there is like some set of questions that is going to come with like 3-4 questions, and he would expect you to solve all of them. Okay, if you, let's say he's coming with 3 questions and you solved only 2, you solved them very well, it won't be a good impression, because he wanted you to attempt all the 3 questions. Okay, so that's how an interview in general works, and you have to communicate things to the interviewer. So that is important. You all can start parallelly building it. Don't leave it to the last module key when I will be actually appearing for interviews. I'll prepare it. Acha, tell me, if I am telling programming will take 6 months to improve, right? 6 months to learn, right? How can soft skills be learned in a single month or in a single week? Right? You can't be, you won't be able to make that fluency. You won't be able to explain it in that crisp manner. So you have to practice it from now. Use these sessions that you have, like soft skill sessions or whatever sessions are going to come ahead, any placement preparation sessions, that is going to be more beneficial as compared to like anything that you would be doing, right? So these skills will help you so you would see like so like for those who use LinkedIn, right? So they would see the developers who are very vocal over there, who speak a lot about tech, who speak a lot about programming, who write those things. They themselves would be in very good companies where they are working, like a senior engineer or staff engineer, or at Google or at Microsoft or something, right? How it happened, right? And there are people who have less experience and they're at senior roles, right? Because they communicated very well in interviews, right? Their communication skills were very good in interviews, and that is also a very good parameter on which interviewers judge you. right? So they judge you based on which you are able to communicate with the team, whether you will be able to explain your problem, whether you will be able to explain your solutions to the team, right? Because there is a complete team effort that's going to be a software. You cannot build a software of your own. There is no engineer who can do it. It is literally impossible. It is almost impossible to build a single feature as well alone, right? You need help of other engineers. You need other engineers uh, with whom you can discuss the pros and cons of your solution, explain them, right? Take their approvals, discuss with senior engineers. When you would be senior, you need to guide your juniors as well, right? So that's how your process is, and communication is very important part in all of them. Okay. So use the sessions, going to be very helpful, right? And start building it from now. Right? Don't leave it till the end, because that is one mistake that a lot of students do. Even me telling again and again, and all the instructions that will come, they will tell you this. Okay. But students leave it till the end कि sir हम तो करते हैं अभी programming, बाद में हम इस पे ध्यान देंगे. We'll keep we'll learn this later. We'll learn this when our interviews is. Don't do that, right? Keep doing it parallelly, and that will really help you a lot while when you will be actually appearing for those interviews. Okay. In the session tomorrow, I guess most likely it would be there like on Saturdays generally, right? Saturdays afternoon the sessions are. Whenever is the next session, you will get informed. Okay. Or your batch managers now like there is a new process where your batch managers would connect with you regarding your soft skills. You'll have more mock interviews. You'll have more one-on-one sessions. So those frequencies are going to increase. Yeah, because this was one feedback which we got, right, from like the companies and even from the students, that they were able to know everything, but the problem was communication where they lagged a little bit. Okay. And the major reason was like they did not pay much attention while developing their technical skills. Okay. So now we are taking this on priority, and we want for the coming batches for all of you and whoever like we are there right now. So we will prioritize this more. Okay. Mock interviews, we won't like mock interviews are lesser in the module 1. We have kept it lesser so that you get used to this platform, you get used to the processes, and you learn something before giving those mock interviews. But I guess one-on-one sessions, those things will open in the module 1 itself. From module 2, everything will be open, right? Your mock interviews, your one-on-one sessions, everything would open, right? Now since we are in basics, so there is like mock interviews and these things won't make too much sense. But in module 2, those things will open, and you would be like having a like flow. You would be get used to working like say 3-4 hours or at least 5 hours every day. So at that point of time, those things will be there. You always have the like access to your batch manager, right? That is there completely for you, right? If you have anything, you have any beginner questions that where do I want to start preparing my soft skills? How, like, I know like my English is good, but I don't know whether I'm very good at communicating it or not, right? Sir, my English is not good, right? I don't understand English. I understand what others people speak, but I'm not able to communicate it in that much better way. I'm good at in my regional language. How can I work on my English? All those things you can shoot those questions to your batch managers. You can take the help of these like soft skills sessions that's there. Okay. And that is going to be you won't see the like immediate deflection, like you see area I teach you, you see the you are able to solve question, but gradually after 6 months you will see the impact, right? After 6 months you will see that yes, my English has improved. My way of explaining thing to other by giving 10 mock interviews or 15 mock interviews or 30 mock interviews, or by talking to one to a mentor, my communication skills has improved. Okay. So that is a long process, but start it now, right? The earlier you start, the more better you will be at the finish line, right? Okay, so let's come back on arrays, right? I'll go in order. Okay, so array operations, like which questions you all have doubts? So array addition is one, right? Array subtraction I'll solve. Okay, these two. Apart from these two, what are the other? Is buildings and second largest done? Some except self. Okay. So this was easy, right? ये तो चलो इसमें there is a trick, just one simple trick that you can follow. So what this array is telling, that you have to print the sum of the entire array except the self. the number, right? So for example, let's say this is your array that you are given, right? Nilesh, you can do like try to get an internship parallelly, but you also need to like improve your DSA skills, because as a fresher for at least I'll say for 3 years, no matter whichever interviews you appear, if it is a like good enough company paying decent salary, they would expect good DSA. Okay. So you need to like even if you know React is now something which a lot of developers know, but DSA is something which other people find difficult to learn, right? So even if you're trying to get internship, that's fine, but try to focus on DSA. That is going to help you more, right? No, I'm not just talking right now, but I'm talking for like all the 3 years, 4 years time frame until you become a mid to senior level developer, where you will where you can just give JavaScript or interviews on that, and you can clear them. But till then, you have to have a good amount of DSA knowledge. Right? Okay. So see, one thing is what we can do is we can find out the sum of entire array. Okay, we'll get the entire sum. Okay. Now, except self, what does it mean? So you have to print the sum minus this particular number. For every number, you have to do that, and you have to print this entire array. Okay, then. So what we can do is we can first find out the sum of entire array, which would look like this. Sum will traverse the entire array, and we'll add every number to the sum. Okay. Let's change this to A. And we can simply add sum is equal to sum plus A of I. Then, and then we can finally print this sum except self. Print I is equals to 0. I is less than n. I plus plus. And what we want to do is we want to print it in a single line, right? So system dot out dot print. It is sum minus A of I. Done. Let's give this input. And let's try to get the sum. Is there anything that I missed out? Okay, it is asking an integer. Okay, it is asking the result in an integer array. Okay, so we can store it in an integer array instead of printing it. We can store it as an integer array, and its size is also going to be the same size as we have for the first array, right? Or instead of like creating a new array, we can even use the same array. So we can just store this in A of I, and we can return it at the end. Okay, sum is equals to sum minus A of I, and we can return it. Okay, I'll talk about a little bit about what this return for arrays means, right? Or what is okay, I'll talk about this little bit. So give you idea of call by reference and those things. Okay, done. Okay, so we found out the sum. We just stored that sum minus A of I into A of I, and we returned A of A array. Okay, so yes, I'll talk about the diamond button. Don't worry, right? We'll do that today, anyways. Okay, any other question? So we can move to the medium questions. There was one triplets, right? Triplets was not here. Triplets is in the next assignment, I guess, right? Where array 2 main. That is on sub that is part of sub arrays. I'll explain sub arrays as well today. Today we'll cover a lot of things on arrays. Then okay. Okay, let me now talk about the second largest number, right? So it looked like a simple problem that you solved over here, but this second largest number is a very good question from the interview standpoint. Okay, so how you should give your actual interview. This is a good like basic guideline that you should follow. Okay, so let's say you are in an interview, and interviewer gives you a question like, let's say you are given an array, and what you have to find out is you have to find out the second largest number in array. Okay. So, okay, someone good candidate would like think of, some candidate would think, let's say, what, okay, so this is the given array. So I need to find out the second largest number, in this case 12. So I have to print it, right? But how did you assume 12 is the second largest number, right? What does second largest number actually mean? You'll say, "Okay, this is simple, right? Second largest number means second largest. Is there any other definition?" So I'll ask you the same question again. Tell me, in this array, what is the second largest number? See, now you all are conflicting, right? Few of you are telling 20, few of you are telling 12, right? Now, you will make an assumption that according to you, either 20 is the second largest number or 12 is the second largest number, right? Yes, sorry, someone is saying something. Okay, so you all made an assumption, right? That 20 will be or 12 will be. But actually, what you should do in interview, if you get the same question in interview to find out the second largest number, should you make that assumption and do it? No. You should ask this question to the interviewer. It is a very valid point to ask question to the interviewer. Okay. Now, what is the question that you should ask? What is the second largest number mean actually? So a second largest number, so the valid definition for a second largest number is there can be two ways he answers. So what does the second largest number mean actually? In case this is the array, which is the second largest number according to you? You should ask this to the interviewer, whether it is 20 or whether it is 12. So if you want the actual second largest number in terms of value, it is 12. Or if you want a second largest number which is in the second position if the array is sorted in descending order, then it is 20, right? So there can be two definitions of second largest number. First is it can be equal to the largest number. That means if you sort it in the descending order, it is like the second number in the list, and it cannot be equal to the largest number. Right? So this can be one of the two definitions of second largest number. Now, whichever definition interviewer gives you, right? Now, for that, you have to write the logic, right? You should not make assumptions in interview that this should be the result, right? This should be the answer. So I'll write my code. What if after writing your entire code, the interviewer says that if this is the input and the second largest number should be 20, it should not be 12, but as per your result, it should be, you will get 12, right? Okay, understood. So why you should ask this question? Okay. So this small questions keep you teach you a lot of things. And see, interviews are a complete different zone, right? There is like a discussion that you're going to have, and every time you get a question, you should ask counter questions. That okay, when we have this, how this should be done? What does this actually mean? Can you better describe this question, right? Okay. Now let's solve for both of them. So let's try to do one question. Let's try to find out the largest number in the array. Okay. So according to the question in the portal, it is 20, right? It is not talked about the actual value. It is talked about when it is in the sorted order, it will be 20, right? See, in this case, both of them are easy, right? So yeah, if in case there is easy or difficult, to think a bit and then ask the easy one. Okay. So whichever one you want the interviewer to say yes. Okay. I mean, if you thought of both the solutions, most likely you would always ask the easy one. Okay. But in case this, right? So the easier solutions look like this, right? Easier solution would be 20 the second largest, where you just sort it and you get this number, right? Achha. Let's check. So in order to find out the second largest, the criteria here interviewer is going to give you is don't do sorting. Okay. If he is asking you the second largest number, he will never allow you to do a sorting on this array. Okay. If you use sorting to find this result, then that is something will not be allowed in interview. Okay. And that is not good time wise as well. Okay. So time wise, it is not better solution. Okay. So now let's see how we can find out the second largest number. So let's do one solution. So before finding out the second largest, let's do one simple solution to find out the largest number. Okay. So how do we find out the largest number? So let's take max, which is integer dot min value. Okay. I took minus infinity as maximum, and I took Okay, and its index is -1. Okay, I checked for every number if a of I is greater than maximum, then I told this is our maximum value and this is the index of the maximum value. And at the end, we simply printed it. Now, honestly, tell me how many of you took this number as -1? How many took the maximum value as -1 and then you compared it? Instead of taking it integer dot min value, how many of you took at -1 or 0 and compared it? Anyone did this? A of 0 is fine. A of 0 is still a better solution. A of 0 is fine. A of 0 still is better. Okay. Why you should not take it as -1 or 0, right? You should not take it as -1, 0. What if the entire array is negative? What if the entire array is an array of negative numbers? If you take it as 0, your final maximum is going to be your final maximum is going to be 0, right? It is not going to be the actual result from array, right? If you take it as 0 and the entire array is negative, so that can be also one clarifying question you can ask, or if like you can, this would anyways be a better solution. Let's say tomorrow the array becomes an entire negative array, then this would anyways be a better solution as compared to the 0 or -1 solution. Okay. Understood this? Now, we found out the maximum value and we also found out the index of this maximum value. Okay, we got both the things, maximum and this index of the maximum value. No, sure. Let me explain you this. So see what we did, we took an array. Okay. Now we took an array and what we did is we told that we assumed the maximum value. What is this maximum value that we assumed is, we assumed the maximum value to be to be integer dot min value. What is integer dot min value actually? So integer dot min value is very large negative integer number like this. Okay. This is the smallest number integer can store, or you can treat it as -infinity for integers. So what I told is, so this is our number line, right? So there are two extremes. At the left end, we have -infinity. At the right end, we have +infinity. Okay. So if you start going towards the left, you keep on getting negative numbers and larger negative numbers. If you start going towards the right, you keep on getting positive numbers and larger positive numbers. So our array would be some numbers in this number line, some numbers in this number line, anyone, right? So I told that whatever is the minimum value that integer can store, consider this is the largest number. This is the maximum. If you see any number in array greater than this, then that is the largest. Otherwise, I'll say this is the largest. If the entire array is storing the minimum value it can, the integer dot min value is the largest number that is present in array. Right? There cannot be any other value smaller than this that you can store in array. ठीक है, इससे छोटा नंबर हो ही नहीं सकता है. ये सबसे छोटा नंबर है जो एरे में स्टोर कर सकते हैं हम, क्योंकि ये सबसे छोटा नंबर है जो इंटीजर में हो सकता है. ठीक है, तो दिस इज द स्मॉलेस्ट नंबर दैट कैन बी देयर ऑन इंटीजर. देयर कैन नॉट बी अ स्मॉलर इंटीजर नंबर देन दिस. So that's why we assume that this is the largest number. Now what we did, we checked if there is any number larger than this. If there is any number which is having value, let's say -10 or -20 or 10 or 12 or 100 or 1000, any of these numbers will be larger than this. If any one of the numbers is larger than this, then that becomes my largest, and the index of that number becomes my index of largest number. I'll again run through this loop. I'll check if there is any other number which is larger than the new largest that I assume. Let's say we got -20, or let's say we got -20, and we thought, okay, -20 is the largest number. Next number we got is 10. 10 is larger than -20, so we'll make this max as 10 now, and the index of whatever it is, that would be our new index of result. Okay, understood how this is working? So you could have taken this as -1 or 0 or a of 0, but this is more of a generic solution which works for all the cases. Okay, clear? Yes, no. Okay. So that 0 solution is having a small drawback in case of second largest. I'll talk about that. Okay. But tell me first, is this clear? Chalo, do a try run. Chalo, let's do a try run. Okay, so this is our number. So this in number is also not present in the array, right? So that's why I took the maximum I is -1. So this index which is not present in array, you can take any random number. I just wanted to give it some number so that here we won't get error. What if I don't give it any number? So it will give me error over here, right? Why? Because this initialization is happening inside if condition. Remember that error? Cannot print a variable which is uninitialized. We'll get that error over here. See, the MXI might not have it been initialized, because if this condition never satisfies, then this will never get initialized. So we have to give some initial value. Now, which initial value should we give? So we give -1 so that since this number is also not present, this integer is also not present. So that's why we gave it as -1. General practice to give -1 for things that is not present in array or something. Okay. Now let's check this. So we assume that this is -infinity and MXI is equals to -1. Now let's check what we are doing in the loop. So we're iterating to the array. So first a of 0. So I is equals to 0. We got a of 0, which is 1. So 1 is greater than -infinity. Yes. So enter inside this, we change this number to 1 and the index to 0. Okay. Next we go and increase it to 1. So is 3 greater than 1? Yes, 3 is greater than 1. So we change it to 3 and the index to 1. Okay. Next we change I to 2. And then we check is 12 greater than 3? Yes, 12 is greater than 3. So we change this number to 12 and this index to 2. Next we check this 3. So is 3 greater than 12? No, this is false. I changed this to 4. Is 6 greater than 12? No, this is false. Changes to 5. Is 9 greater than 12? No, this is also false. Now 6. Is 20 greater than 6 or 20 greater than 12? Yes, it is. We change this number to 20 and the index to 6. Now for 7, again we have 20 greater than 20 and this is false. So we don't have to do anything. Okay, so we get the result is 20 and the index is 6. So now if I run this, we get the result is the number is 20 and the index value is 6. Understood this? Easy. Clear? Okay. Now let's okay, so we found out the largest number. Okay. Now can we use the largest number to find out the second largest number? Yes. So see, the first situation it is telling the largest number can be equal to the second largest number. So if the largest and the second largest number are equal, then what is the difference between both of them? What is the difference between these two in the array? If both of them are equal in value, the difference between both of them is index. Yes. So the difference between both of them is index. So what you have to actually check. So you have to write the same logic, right? You can copy this entire logic, paste it over here, same logic. Just that you have to find out instead of the largest, you'll find out the second largest. So let's call it as second largest and take it as integer dot min value. And let's take SMI second largest index, which is initially -1. Now what we have to check is this second largest greater than so is this number greater than second largest? If yes, this is equals to this and SMI is equals to I. There is only one thing that you have to do. If this is greater than this and the index is not equals to this, so I is not equals to the index which has the largest number, then we'll update this. If the index is equal to the largest number, then we'll not update this. Okay, because that is the largest number, that cannot be the second largest number, right? So the second largest number can be anything, but not the largest number. Okay. Now if I run this system.out.println, that will and print second largest number and the index of it. In one iteration, can you explain, elaborate how will you do this in one iteration? Achha, here you'll do the same check. Okay, got it. Yeah, you can. You will do the same check, but will it work for the largest number? After the largest number, yes. If you write it after the largest number, you can get it as second. No, it won't. But actually, no, it won't work. Okay, chalo, time wise it is not going to be a problem. There might be some way to write it in single iteration. Yes. Let me explain you this one. So we got the largest number, right? We got the largest number and we understood that the maximum is the largest number and its index is MXI. Okay. Now, what I told you that what is the difference between largest and second largest number? If these are same in value, largest number and second largest number can be equal. So if the largest is 20 and the second largest can also be 20, right? If this is a scenario, they can be equal in value. So what is the only difference that they have? The only difference that they have is index. Okay, so the difference that they have is index. They are presented different index. Okay, so now what you need to do is, okay, I'll check your code. Just a second, Nitesh. Let me complete this. Okay, so see, now what we can do over here is, we got the largest number. We already know the largest number. The same logic we can write for second largest. Only place we will not do this swap, where we'll not do this number is equal to second largest if this index is equal to the index which is storing the largest number. Okay, let me do a quick dry run to show you this. Let me make this once a full screen. Okay, somehow fits into the screen. Okay, so let's check. Right, so we got the largest is 20 and the largest index is 6. Okay, what we took for the second largest, we took second largest is again equals to minus infinity, and the value of second largest, index of second largest is again -1. What we are checking over here is, so see, for I equals to 0, we are checking, is 1 greater than minus infinity? Yes. And is the index, current index, 0 not equals to 1? 0 not equals to 6? Yes, this is also true. So this one can be the second largest number. It is currently greater than whatever we have, whatever we already know as second largest. So this is definitely can be second largest. So we store it as 1 and we store the index as 0. Next, we get the I equals to 1, we get 3. We check is 3 greater than 1 and the index of 3, which is 1, not equals to 6. Yes. So 3 is greater than 1. So, okay, it is larger than the current number we have, and it is not the largest number as well. So this can be the second largest number because it is greater than the current number that we have. Okay. So any number that is greater than the current number we have and it's not equals to the largest number can be the second largest. Okay, next number you get is 12. 12 is greater than equals to 1 and 2 is not equals to 6. Yes, this is fine. So the second largest number over here is 12 and the index of it is 2. Okay. Now next is 3 greater than 12 will fail, right? This check will fail. 6 greater than 12 will also fail. 9 greater than 12 will also fail. Now here, look at this particular index carefully. What happens for this particular number? 20 is greater than 12. Okay, this is true, but you also have to follow this 6 not equals to 6. Is this true? No, 6 not equals to 6 is false. Because this is the largest number, this number cannot be the second largest number. So we are getting false from this and we are not updating this second largest. Okay, so if we just have this as array, so you're going to get 20 as the largest and 12 as the second largest. If the largest can be equal to second largest, then it's fine. But in this situation, it is 20 is the largest and 12 is the second largest. Okay. If we have one more 20, so the next number, if for the next iteration, it would satisfy this condition, right? So next iteration, 20 greater than 12, this will be true. And the second condition is also going to be true because this index is different. 7 is not equal to 6 and this is fine. So you are going to get 20 as the second largest number with the index 7. Okay. So now if I run this, you're going to see 20 with index 6 is largest and 20 with index 7 is the second largest. Okay. Understood? Largest, second largest. Yes, Nidesh, like your code looks, your code might work, but it is looking a lot of if-else checks, right? Now these things become a little bit difficult to explain in interviews. That's why I avoid this. Okay. So I write simple code which can be easily explained in interviews, right? So that's why I explain these solutions. Okay. Time-wise, both of them are going to take same time, so not a problem. Understood? Now the second question is first understood the first part. If the largest can be second largest equals to largest. No doubts, right? I don't see any doubts in chat. Right. If you do it is okay. If so, now if this is the first solution when the second largest number can be equal to the largest. What if I tell you second largest number cannot be equal to the largest number? So how does the second largest and largest number differ now? So they differ in terms of actual value, not in the index. Okay. Gopi, I'm just looking into it. Just give me a second. So now it does not actually just differ in index. They are not actually equal in value. So now instead of checking for this just for index, we can check instead of for index, we can check it for value. So let me just copy it, paste it. So here I was checking whether index is not equal. Instead of index, you can check whether this A of I currently should not be equal to maximum. If it is not equal to maximum, then it can be the second largest number, right? If it is equals to maximum, then it cannot be. Right. So now you're getting 12 at index 2 is the second largest number, even though you have 220s in there. Right. Even if you'll have 120s, you'll get 12 as the second largest number. Right. Because in actual value terms, 12 is the second largest number, not 20. No, actually time doesn't work. Time calculation doesn't work in that way, Nitish. So it is little bit different. Yes, there is more iterations over here, but the time wise both of them will be approximately same time. Yeah. Okay. I'll explain the building question. I'll explain all the medium level questions. Don't worry. Right. Okay. So minimum value, maximum value. Yes, yes, I guess that solution is okay. Gopi, I'm seeing your solution. You're finding out the maximum one, which is fine. And then you find out max 2. So max 2 should be less than max 1. And A of I should be greater than max 2, and A of I should be less than max 1. Wow. So it will be when it is not equals to, right? When it is not equals to. So it will only give you the result when it is second maximum is not equal to this situation, right? If it is equals to, if it can be equal to, I guess the portal question is telling can be equals to. The portal question says the second largest can be equal to. That's why you might be getting wrong result, right? So you would get the result like this, which is fine. But for duplicates like this, your result should be 20 as per the portal question. Okay. Now let's look at the portal what it has asked. So let's check over here. Okay, let's check the second largest number, what this question is asking. One lakh arrays 10 times and one times in this is that same complexity. 10 times is going to be not having same complexity. Okay, it is 10n. So 10n is different. I'll talk about this time complexities. So actually you would see, I'll give you one simple way to understand this. See, so I broke this into 2 loops. Okay, and each loops has less number of statements, right? How many statements I've written in each loop? So very few, right? Just one if condition is there, this small statement. You have one loop, but it has so many statements, right, inside it. So if you actually count, if you actually write this n times, so both of them will be almost equal, right? So you have multiple if else inside a single loop. It is similar to writing these 2 if else inside a single loop, right? You're running the same amount of code, right? Actual terms, the amount of code is almost same. If I have more if else over here, right? Or I've just broke it into 2 loops, run this n lines first and then this n lines, right? Number of lines of code is going to be almost nearly same, right? So yeah. So now let's see this particular question here. There is actually I don't have any examples over here, and it has So there is one thing that is given in the question that it has distinct elements. So your second largest number is anyways going to be different from the largest number. Okay, so you don't have to worry about that logic, whether it is equal or not. So you can just write the first one where you are checking whether it is whether the second largest number is having it present as some different index. Okay, that's it. So it just should not be at the index of the largest number. It can be equal as well. So that's fine. Okay, we don't need this. Let's create it as A array and done. And at the end, we can just return the second largest number. Same logic that we wrote. So I'll take your doubts. Right? Any other doubts from apart from these questions? I'll take it at the end. Don't worry. Incompatible types. Okay, it is void. Okay, it is telling us to print them. Okay. We don't need the index. So yeah, I just have found it. We got 5. Let's try to submit it. Okay, done. So in this question, like since the numbers were distinct, no matter whichever logic you run, you are going to get the correct result, right? But if the numbers can be duplicate, then this is a very valid question which you should ask to the interviewer. If you proceed writing the solution without asking this question, so interviewer would definitely assume that you make assumptions and write code without clarifying it, right? So this code is there right over here. So I've written both the code over here. I'll share this link. Now, like from today, you'll get your links from via your batch managers as well. So until this community gets fixed. Okay. Understood. I've shared the link for now. Okay. Okay. We are already over the lunch time. Sorry, dinner time. Okay. Any doubts? Understood this question? Second largest, largest, second largest index. What are these two variations of it? How we can find out both of them? Right? When it can be equal, when it cannot be equal, what is integer dot min value, why we are taking. Okay. Now, okay, one small thing, if for those of you who took this as a of 0, okay, and you would have taken also this as a of 0, okay, right, for second largest number, if you are doing it using two loops, there is one edge case that would fail. What if you took it as a of 0 and a of 0 was the largest number? So what if a of 0 was the largest number? So this condition is never going to satisfy, right? There is no other number which is going to beat this condition. So you are going to get the largest number as the second largest number itself, right? So that is one case. If you are doing it in this way, you have to be careful of. Okay, you have to take care of that situation when if you are taking a of 0 as the largest number. You can check if I not equals to 0, then you take it. Achha, if I not equals to 0, you are taking it. Okay, then you have to handle those cases. Yes, there can be ways to handle it. You can check if conditions where I not equals to 0 something, but be careful of that edge case where the largest number is at the first index. Okay, so you should not accidentally store it as the second largest number because all the other checks will not pass, right? Chalo. Let's me give you a quick 15 minutes break. Have your dinner, come back. We'll discuss the remaining questions. Okay. Hello, everyone. Welcome back. Okay, I hope you all are done with your dinner. Okay, let's continue from where we left off. Okay, any doubts over here? Anything that we discussed so far? No? Okay, so let's see what's next we have right now. Let's see what's. So we completed this. Let's go to this buildings thing, right? Let's see what we have to do over here. Okay, so in this buildings, so what we have is we are given a list of numbers, right? Which is in an array, and what we have to do is we have to print the towers of that particular height, right? So for example, let's take this one. So this array instance. So here we have like the first number is 9, so the first tower would be of height 9. Then the second number is of 3, so the second tower would be of height 3. Then there is the like third tower which is having height 7 for corresponding to number 7. Then we have fourth tower height 6 corresponding to number 6. Fifth tower of height 2 corresponding to number 2, and then 0 and then 4. Okay, so every number in the array has a tower of like stars associated with that. Now one quick question: if I represent this in form of stars and then there are numbers in the array, what is the highest tower height going to be? What is the largest height of tower going to be? Max number? Max number in the array, right? So the highest height of the tower would be going to be the max number. Okay. Now what is the like okay, let's say we find out the max number, so whichever number matches with the max number, that is going to have a star in the first line. So for example, if there was one more 9 over here, there would be one more tower with height 9, right? So let's say there is one more 9 over here. So there is going to be one more tower at the end with the height 9 stars. So in the first line, okay. Now in the output screen, when we print something, we print it in the line-wise fashion. We cannot print it vertically, right? There is some way to print it vertically, very complicated. We don't know that. Okay, but we can print horizontally, right? So we can print horizontally. So once I print for, let's say, the first number 9 stars. So if I just try to print the 9 stars for the first number, I'll print it first line, second line, third line, and so on. Because first, second, third, fourth, fifth, so on. Now I can't go back to here, right? I can't go back to this particular space in the line that we have, right? So we can't print that thing over here. Okay, we can't go back to any lines to print it. So we have to figure out a logic such that we can print the stars in each line in every iteration of array. Okay, so what we can do is see. So this question can be solved by using nested loops. Okay, so nested loop on a single dimensional array. We already know how nested loops work. So what we need to do is first is we have to find out the maximum value in the array. That's already found. Okay, it has not given it. Okay, why is it found out there? I guess. Yeah, someone wrote this by mistake. I guess. Not difficult. Yeah. So see. So what we have to do is we have to find out the maximum number in the array. Now, once we find out the maximum number, so whatever is the 9s, that many 9s, that would be the stars over here. Now, just tell me for the second line, which numbers are going to show stars. For the second line, the maximum values. So, for example, if there is 2 more 9s, they are going to have stars in the second line. 3 is not going to have 8, 7 is not going to have 6, not this not. If there is a 8, that is going to have a star in the second line. Okay, so second line, if there is a 9, that is going to have a star. If there is going to be, if there is a 8, that is going to have that is going to have a star. Okay, so first line, all the numbers that were equals to 9 had stars. Second line, all the numbers which were greater than or equals to 8 had stars. Third line, all the numbers which are greater than or equals to 7, they will have stars. Yes. All the numbers which are greater than or equal to, so any number which is greater than 7, that will have stars, that will continue the stars. A 7 is going to have a star, right? Any number smaller than 7 is not going to have stars in this particular line, right? So now we can like, are we seeing the logic some here, some logic over here? So we can find out the maximum. We can print the stars like which is equals to the numbers which are equals to maximum. There are those stars in the first line. And then we can decrease, keep on decreasing maximum by 1, and whichever number is greater than or equals to this value, we'll keep printing stars for that. Right? Sounds fair? Let's check this, if this works. So what we can do over here is, we can the one additional bracket. Yes, this is fine. Yeah. So now we can firstly find out the maximum. Let's call it max. We already show how to find out the maximum. Integer dot min value and we can do for int I is equal to 0, I is less than n, I plus plus. So if maximum is greater than a of I, then that is our new maximum. Right? The maximum, sorry, maximum is less than a of I. Then a of I is our new maximum. Then once we got the maximum, then what we have to do is we have to print the stars in each line. So how many lines we have? So we have to print as many as maximum lines, right? So we'll print the number of lines we agreed that it is going to be the highest height of tower is going to be equals to maximum. So you have to print maximum lines. Okay. Now in the first iteration, let's take, so in the first iteration, let's take a variable p, which is equals to max. Okay. Now in the first iteration, what we have to do is we have to go through each number in the array. We have to visit each number in the array and we have to check which numbers are greater than this. So we have to go through each number in the array and we have to check which numbers are greater than this maximum that we have. So if a of I is greater than or equals to p, which is the maximum, then we print a star for it, right? System dot out dot println print, right? Print, we print a star for it. And here there is one thing that this is not a single space, this is a tab space. Okay. I don't think this is mentioned in the question, but this is a tab space, this is not a single space. That's we already know about escape sequence, how we can print a tab space. We can use /t. Okay. Else we can print a simple tab space. At the end, if this prints the first line, we can simply print println, change the line. That's it. We copy this, we paste it over here, we run the code. We are getting index out of form. Okay, sorry. Okay, we also have to decrease this A of j. We can check for A of j and we can just decrease this up. Not here. Sorry. We have to decrease it over here. But only tab space we have to print. So if for tab space we just can print like /t, that would be fine. Okay. Yes, you can check max minus I, that is also fine. Yes, that is also one way you can check if it is greater than max minus I plus 1. It would be max minus I plus 1 actually, that would also be fine. Or you can take another variable which stores max and you can decrease this variable after every statement that you're printing. So see, this inner loop is basically printing each line of this tower, right? And this outer loop is printing the number of lines. Okay, now /t. So /t is basically printing a tab space. So this represents a tab space. So here in the question, there is no mention of this. Actually, it should have been given, but this question, this space that you see over here in between these two stars is a tab space. Okay, so first character we print a tab space, and for like if it is not a star, we just have to print a tab space. So what is the difference between a tab and a normal space? A normal space is a single space, but in a tab space is a like bunch of spaces. So for example, this is a single space. Okay. Now, what is a tab space? So here, let's say this is a singular space. This is a tab space. Okay. Check this. So this is a single space, and this is a tab space. Okay. If we submit, but instead of star, we need to print a space, right? That's it. No, so in here it doesn't work that way. So in case of tabs, so if you already have a character, you don't need to put a space for that character, right? So it will automatically take that character into it in the account. Okay. So basically, if you how do I explain this? See, so let's say if I give a tab space, it's going till here, right? Which where I print A. Okay, and let's say if I write A and I give a tab space, see, it is still going to the same line. Just look at it. So if when I did not have a character over here, and I just print a tab space, okay, from here I print a tab space, it is going to this particular value, right? This is how tab works. And here, if I have a character, even though I have typed a character and I try to print a tab space, see, it is going to the same space, right? Okay. So tabbing basically is So tabbing, for that you just need to pass /t. That automatically will be handled by this. I'm printing it row by row. Yes. So the first thing we are printing it row. There is no way to print it column by column. There is like very complicated way to move pointers after you print it. Yes. Let me explain this from scratch. Right. See. No, that is not error in test case. That is how tab works. Yes, I know this is a little bit confusing in while writing it here, while there is no space over here. Okay.
सर स्क्रीन फुल कर दीजिए कोड का.
Okay. Yes. Let's do this one. Is this full means anything? What's this one?
Sir, console पे click कर दीजिए. He meant that.
This is fine. Okay. I guess this is better. Okay, let's do this. This is actually better. Okay, this is fine. Right? We can anyways look into this. Okay, see. So what we are doing over here is first we find out the maximum number, right? So this logic was simple. Finding out the maximum number, that we do not have any doubt. We already know okay, how we found it out, right? We have already done this. So this is like plain logic. Take a maximum value, integer dot mean value, compare it with all the numbers, and then we like find out the maximum. Once we find it out, we store it in a variable, which is like which is by storing it in some other variable. Okay. Now what we can do over here is, look, once we found out this maximum value, we stored it in this particular variable. What we have to print is this pattern. Now this pattern will be printed in the row wise. So for example, we can print one row at a time. So for example, if I want to print, I would be printing this row. Okay. This row specifically, I can't print it column wise. So now how can we print this row, and for which values do we need to print stars? So firstly, I figured out what is the total number of lines. So for printing any pattern, we need to know total number of lines. So outer loop is going to run for number of lines. So what is the total number of lines over here? Maximum, whatever is the maximum. So that many lines. So outer loop is running for number of lines. Inner loop runs for how many values you want to print in each line. So in each line, I want to print n values. Now, depending on whether like it is, we may print a star or we may print a space for it. So for example, here we are printing a star, for this we are printing a space, for this there is a space, for this there is a space. We might print spaces as well, or we might print stars as well. Okay, now that would depend on what? It would depend on what's the value of it is, right? So if the value of it is greater than or equals to p. So for example, let's check. So for first iteration, when p is equals to maximum, in this situation, max is 9. So we got max is equals to 9 and p is also equals to 9. So first iteration, p is equals to 9. So a of 0, is it greater than equals to 9? Yes, 9 is greater than equals to 9. 9 is greater than equals to 9. So this satisfies. We print a star, we print a tab space. Next iteration, 3 is greater than equals to 9. No, it doesn't satisfy. So we print a space, simply just a tab space. Next iteration, 7, is it equals to greater than equals to 9? No. So we print a tab space. Same goes for 6, 2, 0, 4. We print a tab space and everything. We don't print any stars for anyone else. Okay. Next, p changes after we are done with printing one line of this pattern. We come outside. We change the value of p. It becomes 8. We change the line as well. So now we come to the second line, which is this. Okay, so we printed the first line. Now we are in the second line of this output. Now here, what we can do is when we are in the second line, we can again check all the values. So we'll check if 9 greater than equal to 8. Yes, so we'll print a star for it. 9 is greater than equal to 8, so we print a star for it. Is 3 greater than equal to 8? No, we don't print any stars. Is 7? No. Is 6? No. So we don't print any star. If there was any 8, we would have printed a star for it. But since there is no 8, we don't get any stars. Now this changes to 7. We move to the next line, which is now the third line. We check is there anything greater. 9 is greater than equal to 7, so we print a star for it. 3 is not, so we don't do anything. 7 is greater than equal to 7, so we print a star for it. No. It should not be space. There is no space. That's what I was explaining. So in the case of tab, it doesn't work this way. You don't need to add a space over here. See, when you're printing a tab, okay, so let me just give an example over here. So let's say your A is over here, okay, and I give a tab space. So where my iterator is over here. Yes, acha. I wrote a character and then I gave a tab space. And now look, if I give a tab space and I write a character. See, both the scenarios I end up in the same space. Okay. So if you write a character, you give a tab space, or you already have a character written, that here I was, right? After writing a star, I already was there, and I give a tab space. So I am anyways going to be over here. Okay. So if you write a character, that one space gets reduced from the tab. Okay. So this if you write a character and you print tab, so there is one less space. And if you don't write the character, print it directly tab, there is one space greater. Okay. So that is how actually tab behaves. That is a behavior of tab. If I write 3 characters, it would actually reduce 3 spaces. Comment. Okay, got it. Yes. Clear. P minus minus. So basically, after printing every line, we want to decrease this P, right? So that for the first line, we are checking with the maximum value. So we are first line, it should be equal to 9. Second line, we should be equal to greater than equal to 8, right? So for 8, there should be a star. So that's why for second line, we decreased it to 8. And then for third line, we decreased it to 7. For fourth line, 5, 6, 5, 4, 3, 2, 1, and 0 finally. Understood? So every iteration we are decreasing it so that we so the next time we check for the lower values. For 9 we got stars, for 8 we'll get star, for 7 we'll get star, for 6 we'll get stars. Okay. It looks medium, but code is simple, right? The only thing that you had to figure out was this. So code is going to be simple for all of them, right? So code is simple for every question. Just that questions might be tricky. Okay. So array problem 6. Let me complete this. Then we'll be left with only 2 questions over here: addition and subtraction. Okay. No doubts on this one, right? So we can conclude this. Buildings clear. Okay, I'll not solve subtraction today. I'll give you hints on that. Try to do it. Take a face hurdles, face issues, and then I'll explain it. Okay, I'll give you the solution. Okay. So what's this array problem 6? So write a program to find out the shortest distance between 2 even positive integers. Now this is a big yeah. I'll do addition. Addition I'll do today. So this is a big this is 2 things put together, even positive numbers. Okay, the number has to be even and positive as well. So -2 is an even negative number, so we don't have to take such number. We have to take even positive numbers. Okay, and we have to print the distance between them. So if there is 1 or 0 even positive integers in the array, then we have to return -1. See, if there is a single even positive integer or no even positive integers, we return the distance as -1. Otherwise, we return the distance as I minus j. Acha. Do we know a mathematical function that does this work for us? What is this operation? This operation is known as absolute value of this math.abs, right? I told you there is a math.abs function which gives you the absolute value of any subtraction. So for example, let's say if this subtraction gives us a negative result, say a minus b gives us a negative result, or I minus j. If I minus j gives us a negative result, you want just the positive value out of it. So let's say if this is minus 10, we just want 10 out of it. Right, and if it is 10, you want 10, right? If it is positive, then you want 10. Which operation gives you this? Modulus, which removes negative, and for positive number doesn't do anything. Okay. Even if we don't know that mathematical function, we can write that logic ourselves. If the number is greater than 0, just multiply -1 to it. Okay. So now let's say what we have to do is, so we have to find out two even positive numbers, and then we can find out the difference. Okay, between them. So let's run this once. First, let's write a simple solution. So what we'll do is we'll pick one even positive number. So let's say, let's take example of this array. Okay, here what we want to do is we can pick one even positive number. Let's say this. And we'll stick to this number, and then we'll try to find out the second even positive number to the right of it. Any even positive number to the right of it will find out the distance between them. So the distance between these two is 1. The distance between this is not even positive. These two is 3. So my largest distance is 3. Okay. Is there anything? No. There is no even positive number. Yeah, we have to find out the smallest one, I guess. Largest नहीं find करना. Yeah, shortest distance find out करना. Yes. So the shortest distance here is 1. Okay, done. Achha. Then we'll pick 1, and then we'll go ahead and we'll find out the next even positive number, and we'll find out the distance between them. So here it is 2. So we already have a 1, so which is our result, right? There is no other even positive number, so we won't find the distance between them. So we can write it using 2 loops. First loop will find out the first even positive number. We'll pick that. We'll then go to find out the second even positive number to the right of it. If there is any other, we'll find out their distance. Now, whatever is the distance, we'll find out the minimum between them. Okay. So let's take smallest, which is, let's say, equals to integer dot max value. Okay. So we take a smallest, which is equals to integer dot max value. That this is the minimum distance. Okay. What we can do is we can write a loop for int I equals to 0, I is less than n. We can go to the entire array, and we can check if the current number is even positive. How do we check if a number is even positive? So it should be divisible by 2, %2 double equals to 0, and this a of I should be greater than 0 as well. Okay. If it satisfies both the condition, that it is divisible by 2 and it is greater than 0, that means it is even positive, right? Now we found out the first even positive number. In this case, we'll get 2. So what we need to do is we need to find out the second even positive number, and we have to find out their distance. Okay. So second even positive number can be any number from the right to it, right? So we can pick any number to the right. So we can start with I plus 1. We can check j is less than n and j plus plus. Okay. If a of j, the second even number that we got, %2 double equals to 0, if this is even, and if this is positive, right? So we found out our second even positive number as well. So this was our first even positive number we got, and corresponding to this, we got another even positive number to the right of it. Okay. So we can find out the distance int d, which is equals to I minus j, and we can take its absolute value, right, using math.abs. Or it is anyways going to be j minus I is always going to be positive, right? So you can take j minus I, which is always positive. Okay. Now you just need to store it in smaller. Smaller is equals to math.min, whatever is the minimum between the current smallest we have. Whatever is the minimum between the current smallest we have and the distance we got. At the end, we can simply return this. Now why j minus I? See, so j minus I is the distance between two even positive numbers, right? That's what the question does. That's what the question is telling. The definition of distance between two even positive numbers is j minus I, right? So the definition of distance between these two even positive numbers is I minus or j minus I, whatever is the absolute value. Now here j is always greater than I, so we can take j minus I, which is always going to result in a positive value. Okay. We can find out the minimum between all the numbers. That will give us the minimum result. Okay. So let me paste this, run this. Okay. Now the last thing, there is one last check. There is one thing taken. Now for this we are getting 1, but for this question we won't get 1. We would get integer dot max value, right, for this particular input. So we have to check that case additionally as well. Okay. See, so we are getting the largest value. Do we have to print this? No. So if this is equals to integer, so you can use the if condition. I'm just writing a ternary operator. Integer dot max value, right? If this is equals to integer dot max value, then what we have to do? We have to return -1. Otherwise, we can return the smallest number, right? So now in this case, if this is equals to integer dot max value, so in that case, we'll return -1. Okay. Otherwise, whatever result we got, we'll return that. Okay. You can use a if else condition and write returns. That is also fine. This is like I'm writing it in a single line. Something went wrong in the compiler. Okay, understood. Let me check your code. Rishikesh, have you shared any code? Okay. You found out whether it is even positive. You increase the count. Next, if count is greater than 1, then you do this. You find that is fine. Two numbers, minimum distance, I minus j minus I. Yes, that's fine. Same logic, right? You have just checked it inside. Yeah, that's fine. Otherwise, returning minus. Yes, that's correct. Rishikesh, that's correct. Same logic, same thing. Acha. Now tell me first thing, everyone understood this thing, what we have done. So firstly, I found out the first even positive number. Okay. While lesson working, if we are on the last index. So last index is n-1, right? Last index is n-1. So n is the length, right? N is not the index. N is the length, n is not the index. So let's do a quick dry run. There are other solutions and there are better solutions than this as well. Okay. But this is the easiest one to understand. This is the first solution that would strike to you. Okay. You smell आ रहा है कुछ ऐसा कपूर का? चेक कर लो कुछ फायर तो नहीं लगा हुआ है पूल में? फायर कुछ जलने का स्मेल आ रहा है. चेक करके देखो किचन में तो कपूर रखा हुआ था. Okay, sorry. Yeah. So let's check a dry run on this code. Okay. So firstly, we have like is smaller, which we have stored plus infinity, right? So it like we have just taken a very large number so that we can check whether the distance is smaller than this at least. Okay. Now what we are doing is for every array. So firstly, I have written an array equation, and what we are doing is we are checking is this number even and positive. The first number, yes, this number is even and positive. So we go inside this and we take a j. So I equals to 0. So and for that, this is a even positive number. So we go inside and we check, we start a j loop. Now j is equals to I plus 1. So j will start with 1 and will go till the end of array. Okay. Now we are checking is a of j. Is this a even positive number? Yes, this is a even positive number. So what we are doing is we are finding out the distance j minus I, which is 1 minus 0. We got the distance as 1. Now we are finding out the smallest number. So we found out the smallest number between plus infinity and 1. Which one is it? It is 1. So we'll change it to 1. Okay. Next, in the next iteration, j will change to 2. We'll check 1. Is 1 even positive? No. Next, it will change to 3. Is 3 even positive? Yes, 3 is even positive. So we find out the distance between them. So it is 3 minus 0, which is 3. Is 3 like 3 smaller than the current smallest we have? Which one is smaller between 1 and 3? 1 is smaller, so we keep 1 as the result. Okay. Next, we like increase j to 4. We check 7. Is 7 even positive? No. So we don't do anything. Okay. Now j loop ends. We increase the I value, right? And we find out the next even positive number is 4. Right. So next number we start with 4. 4 is the even positive number. So we check for all the numbers from the right. Okay. So is this even positive? No. J equals to 2. No. J equals to 3 is it even positive? Yes. J equals to 3 is even positive. So you do 3 minus 1, which is 2. So 2 is not less than. So for last index, it will not, this condition will be false, right? So it will first check this condition and then it will be false. Right. So for this would be false, right? If for j equals to I plus 1, when you are at last index, let's say this is the number. So you don't have any other number to pair it up, right? So let's say this is 8. So there is no number with which you can pair up. Right. So let's say you take 2, 4 or you take 4, 2. Both of them mean the same thing, right? The distance between them is same. If you take 2, 6 or 6, 2, the distance between them is same, right? So I just took 2 and I just found out all the even numbers to the right of it. If you take 4, you look left side, you have already taken that pair. So 2, 4 you have already taken. So there is no meaning of taking 4, 2. That means the same thing. Understood? Yes, no. जाओ फोन रिंग हो रहा है कोई okay understood okay clear chalo let's move to another problem then I'll explain array subtraction. Don't worry, right? I'll give you hints today. I'll give you some more time to try that out, right? So array subtraction is the problem I do not expect you'll be doing by today. I'll give you some more time, solve some more array questions, to, handle these edge cases, and then solve it again. My point here is not to solve more questions and show you how it can be solved. My point here is to give you idea so that you all can work yourself in finding the solutions for this, right? That would more help you. Okay, so that's why I won't solve that question today. We'll do it. I'll definitely solve it. Okay, I'm not going to go away without solving that question, but not today. Okay, but I'll solve the easier one so that you see some array questions, some array manipulations. For example, this was new thing, right? How we can find a pair of something. So if you already have a number, how you can find a pair of it. Okay, so those things we say seeing for the first time. Okay, now understood this. Okay, is this clear? Then we can think of something. Okay, Ajay, tell me one thing. Once let's say you found out you took a I, you took a J, you found out the difference, and we are finding out the smallest, not the largest, right? If you are finding out largest, that's different. But here, since we are finding out the smallest difference between them, right? So tell me that this is I and this was the J. Let's say this was the J. Now, keeping moving J's to the right side, okay. Can you get a smaller difference? Say if we are finding j minus I, and if j is increasing and I is fixed, I is a fixed number, can this difference be smaller? So let's say you do 2 minus 1, and then you are increasing j to 3 minus 1, 5 minus 1, 6 minus 1, you are increasing j and I is fixed. Can this difference be smaller or it will get larger? The difference will not be smaller, it will get larger, right? So once you found out one difference, do you need to find out any difference in the right of it? you actually don't. So you can simply break over here. You can simply put a break over here, so that once you find out the difference, you don't need to see. So now still we are getting the correct result, which was -1 in this case. If we submit, it will still work fine. Okay. Now we're avoiding a lot of iteration. Think of a very large array, 10,000 or something, right? No, we are not finding that distance. The distance has nothing to do with values, right? The distance is, if the distance was related to values somehow, then we would, we can't break over here, but the distance is not related to value, it's just related to index, and index moving right will simply increase, right? Understood? Yes. See. So why did I add a break, and how does it not change anything over here? So see, what we have done over here is we have taken a make I here, simple. I is over here, and then we have J, which is going towards the right. Okay, so J is going towards the right. So this is J, this is J. Now let's say we got a J over here. Okay, you found out this is a even positive, this is even positive. Found out the difference. Now you are finding out how are you finding out difference? J minus I. So for I fixed, let's say we fix the I is fixed, right? I won't change in the inner loop until you go to the outer loop, increase I is not changing in this iteration of loop. So I is fixed for the inner loop. So let's say I is 1, 0 or whatever it is. And you're continuously increasing J. Every iteration J increases to some new value, which is higher than it. So let's say this gave you the difference as 1. Now all of these is going to give you higher difference, 2, 4, 5, 6, so on, right? These differences are going to be higher. These are not going to be smaller differences, right? So you don't even need to calculate this, since we are only interested in finding out the smallest difference, not the largest, or the difference is not related to the value, right? So we can simply break over here because the difference is not related to values, and we just want to find out the smallest difference, not the largest one. Understood? Yes, no? Okay. So if understood, let's move to the next question then. Okay, no, there is one more thing to explain on this last thing. Okay. Okay. Now, is there any other way to solve this? Is this the most optimal code? No, there is a better code which is optimized than this, which can be done using 2-pointer, and we can do it using a single loop iteration. We don't know 2 pointers, but it is very easy, right? It's very easy to understand. I'll give you a simple idea. Acha. Can you think of writing this logic in a single iteration? Anyone can come up? Anyone can think of any solution? There's a bug that is flying around. Anyone? Anything that you can think of? Acha. Tell me, for this 2, if I get any nearest even positive number to the right of it, with this 2, this is the smallest, this is the smallest difference that we can get, which is 1, right? There cannot be any difference smaller than this, right? Do you need to check 2 with 6 or 2 with 8 or 2 with 12 or 2 with 18 or 2 with anything else? 14. You don't need to check it with anything to the right of it. If you just check it with its next even positive number, you don't even need to do this. Acha. Now, let's say we got this as difference is 1. The next even positive number is 4. So this is our now even positive number. Whatever is the next even positive number to the right of it, that is going to be the difference between these 2, and this is the smallest distance that you can find between 4 and any number to the right of it. Yes, which is even positive. So the smallest difference with 4 is to the right of it is 2. Okay. If smallest is equal to 1, then break the outer loop, but it might not. So this number might not be 4, right? This number might be like, let's say 1 or something. Okay, so the difference for 2 you'll get is 4. So for 2 you'll get is 3. For 6 you will get is 2. Okay, and then for 12 you will get is 1. right? So here the smallest difference is this, which is 1. This is a difference 3. This gives a difference as 2. Okay. So now what you can do is, so I'll give you a simple idea of how it will work. So basically you will traverse the array once, okay? Arrays through a single iteration. You'll try to find out the first even positive number. This is the first even positive number. So you don't do anything for it. Now, once you found out the first even positive number, you look for the second even positive number. So let's say you got this as the second even positive number. Okay. So you'll find out the difference between them. What is the difference? 3. So your minimum is 3 for now. And this is my new even positive number for with which I want to find out difference. Next, I got odd, so I don't have to do anything. Next, I got a even positive number. So I'll find out the difference between these two. See, I don't need to find out the difference between 2 and 8. I just can find out the difference between 6 and 8. Why? Because 2 and 8's difference is always going to be higher than 6 and 8. Right? So I can take this difference, which is 2. So which is smaller than this. So I update my smallest to 2. Next, I take the next even number, which is 12. Okay, now this is a even number, and this even number is also this. Last even number we saw was 8, and the new even number we are seeing is 12. Both of them are positive, so the difference between them is 1. Now we take the difference as newer smaller is 1. Then we find out the next even number, 18. So we find out their difference is 1 also, so it's still 1. Okay, 13, and then the last number we found is 14. So the difference between 18 and 14 is 2. So we still have 1 is the minimum. So we finally get 1 is the minimum value, which is the minimum difference. Now, yes. And firstly, tell me, got some idea, glimpse of how we can think. So you can simply iterate through it. You will store the index of the last even positive number, right? And you just need to find out the next even positive number. So let me write some code that will make it a little bit easier to think. We actually did not do this using break. This did not happen. So for even if we are using break, we are checking 2 with 4. Okay. And then we are checking 6 with 4 with 6. And then we are checking with 6 with the next number, and we are traversing this again. Are we actually okay? This would actually result in the same complexity wise, but we actually have 2 loops doing the same thing, right? So complexity wise, it would be still same. But we can write it using even a single loop. We don't even need these 2 loops. Okay. So my point is, do we actually need 2 loops, or can we do it in simple loop? So let's say we store last ls or lt. What this gives us? This gives us the index. This gives us the index of last even positive number. Okay. So the last even positive number starting is -1. Okay. I write a simple loop. I is equals to 0. I is less than n. I plus plus. So what I check for every number, if a of I %2, if this double equals to 0, and a of I is greater than 0. So this is an even positive number. Now what I need to do for every even positive number, I just need to find out the difference of the index. So if the last index that we have is equals to -1, that means this is the first even positive number. So we don't need to do anything. We just need to store the last index is I. Okay. Okay. And if we already have a last index, that means the last index is not -1. That means we have a even positive number to the left of it. What we can do is we can find out the difference. So what is the difference? Difference is equals to the current index minus the last index that we have. We can find out the smallest is equals to math.min, which is current smallest plus comma d, current smallest comma d, which is the minimum of this, and then the current index becomes our last index. So now this is the last even positive number that we have. Now if I run this, if this condition never satisfies, we have only one even positive number. On those all situations, smallest will be integer dot max value, will get -1. And if there are multiple, if there are multiple even positive numbers, this condition would satisfy, and we'll find out the difference, and we'll take the minimum of those. Okay. I'll explain this. Sure. Okay, let's submit it. It also works. Now, it is also having, if you know about time, same complexity, same thing, just that here we had 2 loops, and here we are trying to do the same thing using a single loop. Firstly, tell me one thing. Just a second. Okay. Let's look here, right? So the first, okay, let's look over here. So this logic everyone understood. Everyone understood what we are doing over here. So for every number, we are going to the right. We are finding out the next even positive number. We are finding out the difference between them, and then we are telling, okay, this is the difference between them. We are checking whether it is smaller or not, right? If it is smaller than the already smallest value we have, then this is the new smallest. Otherwise, it is not. Now look at this logic. Okay, just look at this logic of what we are doing over here. So let's take this particular array as example, which is a larger one. Okay, this one as example, which is a larger array. Let me erase everything else. So just look at this logic of what I have done. I have taken one single variable, which is sorry. Just a second. There's something that is happening on the screen. Yes, I can see this. Yeah. Okay, look at here. So what I did, I simply took a variable which is LT, which is equals to -1. Okay. Now, I assume that initially there is no index having a even positive number, so it is -1. Now I started traversing the array and I checked if this index I equals to 0. When I am I equals to 0, is this index even and positive? Yes, this is even and positive. So is the current LT equals to -1? Yes, it is -1. So we don't have any even positive number yet. So this is the first even positive number. So let's make this index as the first even positive number. LT is equals to 0. Okay. Next, I increased I to 1. I changed to 1. Okay. And we saw, okay, I moved to here. Now, is this even positive? No. Okay. So we changed I to 2. Is this even positive? No. We changed I to 3. Is this even positive? Yes. So this is the even positive number. Now what we do, we enter inside this. Is LT equals to -1? No, LT is not equals to -1. That means we had a even positive number to the left of it, with which we can find out the difference between or distance between both of these numbers. So what we are checking over here is, we are checking that, okay, what's the distance between them? The current index is 3. The index of the last even positive number was 0. Yes, yes, it was 0. 2 was the last even positive number. We do 3 minus 0, which is 3. We take the minimum there. So smallest is 3. Right? Smallest was right now integer max value. So we now store it as 3. Okay. Now this current number became our last even positive number, because going forward when we get 8, so we don't want to find out the difference of 8 with 2. We want to find out the difference of 8 with 6. So we are updating our last even positive numbers index with the current index, that is 3. Okay. Now I increases to 4, right? We check, is this even positive? No. Is I increases to here? Now this is even positive? Yes. Now we come inside. Is LT equals to -1? No. You go to the else part. So what was the last even positive number? Right. So this is 5. Sorry. What was the last even positive numbers index? 3. What is the current index? 5. So we do 5 minus 3, which is 2. Is the distance between them 2? Yes. So first distance we found out was this. Second distance we found out is this. Is this less than the minimum? Yes. We change the minimum to 2. Okay. Finally, we take the next number. I changes to 6. Okay. We also update it to 5. After this, we update it to 5. I changes to 6. We check the index. Is it even positive? Yes. So we find out the difference, 6 minus 5, which is 1. We change this to. Okay. So we got the distance between these two as 1. Next, we'll get the distance of these two as 1 and these two as 2. So the final minimum is 1, which we'll store it. Understood? How this is working? So we did a single iteration. Initially, we assumed that there is no this is clean code. The logic is same, right? The logic is same. The time wise, if you know, that is also going to be work in the same way. But this is more clean, right? This is using a single loop, and that used two loops looked a little bit more complicated. Had two if checks like this. This is a single code line of code, and this is cleaner. This is easier to understand. Okay. And both of them works, right? So understood? Okay, try to write your own code like this. I don't share generally the codes of these assignments so that you try it, that you understand the logic and you try it yourself, right? So this is like just to give you idea about the logic. You should try it, writing it yourself. I'll not share this code. If you get stuck, let me know. Well, I'll share this code. I'll help you again. But try this today. Try if you have done it using multiple loops, try to solve it using a single loop. Okay. So we don't have time for array addition, but I'll give you idea. Just see. So here for array addition, right? Array problem 5. Yes. So I'll give you 2 problems. I'll give you just idea. We'll solve them tomorrow. I'll give you solutions of them tomorrow. And today, like you can complete this assignment. Spend little bit more time if you have questions left on here. And arrays 2, you can start. Okay. Arrays 2. Okay, there is one sub array. Okay, part. Sub arrays I'll start with tomorrow. Sub array and 2 pointers I'll explain you tomorrow. Okay. Apart from that, the remaining is like normal array questions. But yeah, the array 2 is a little bit more difficult assignment. So geometric triplets is very easy. Like it's like a very easy question. I guess यहाँ पे ना there is some problem in the test case of this question. Okay, so I guess this was one question which test case was wrong if I recall it correctly. Okay, so I guess there is some erroneous test case over here. Otherwise your logic would be fine. Okay. I'll validate this tomorrow. Okay, I'll check that tomorrow. So this is today's assignment. You can try it. Probably you'll be able to do rotate array, divisible sum pairs. So these things you'll be able to find out. Subarray question, maximum subarray sum. So that I'll explain tomorrow. Subarray, you can try, right? So that will get you idea. I'll explain them in detail tomorrow. Okay. Let's check array problem 5. Okay, understood. See, so let me explain this question. Largest number at least twice over the okay. Array problem 5. So what is this question telling? So here you have a array, right? Now what you have to do is you are given an integer k, you have to find out such consecutive pairs of a array element whose sum will be k. Okay, I'll give you hints for all of them. So I'll give you hints on the top of which you can try these questions at least. So you have an array, you have an integer k. What you have to do is you have to find out the number of consecutive pairs of array elements whose sum will be k. So what is consecutive pair? Consecutive means 2 consecutive numbers, right? I and I plus 1. So I and I plus 1 index is the consecutive index, right? So you have to check whether their sum is equal to k or not. Simple. So for example, let's say you do a single traversal of array. Okay. Single traversal of array. What is the consecutive number for I equals to 0? What is the consecutive number? What is the consecutive index for I equals to 0? I equals to 0 के लिए consecutive index क्या होगा? 1, right? So I equals to 0, the consecutive index is 1. Okay. For I equals to 1, what's the consecutive index? 2. For I equals to 2, is it 3? For I equals to 3, is it 4? Or in general, I can say for I, the consecutive index is I plus 1. So what you have to find out? You have to find out whether a of I plus a of I plus 1, whether this sum, right, is equal to k. If this sum is equal to k, then you have one such pair. If if there is any other I for which you have this sum is equal to k, then you have found one more pair. If for any other I you found this is equal, then you found one more pair, and you have to just print the count of such thing. We already did how we can count prime numbers, how can we count factors. Now you can use same count logic, initialize it 0, increase it every time you find this condition is true. And that should work. What's some idea? थोड़ा सा कुछ चमका बस दिमाग में स्ट्राइक कर रहा है कि हाँ ऐसा कुछ तो कर सकते हैं, right? There is one edge case that you need to handle when I will be n-1. For the last number, what is the pair? For last number, there is no pair, right? So last number, there is no pair, right? Now handle that in loop, right? Otherwise, you'll see index out of bounds. Okay. Think of this. We'll get the solution. Next is largest number, largest difference. Okay, largest number at least twice of others. Okay. Yes, we have to go till n less than n. So that's correct. Okay, so what you have to do is you have to find out, we are given integer number n and where the largest number is unique. Okay, largest integer is unique. The task is to determine whether this largest element in the array is at least twice as much as every other number in the array. If it is, print the index of the largest number, otherwise print -1. Acha. First, tell me, let's break it into, let's think it in small problem. So let's say we are given an array. So can we find out the largest number? Before checking anything on the largest number, we need to know largest number. Can we do this first step? Find largest? Yes, absolutely. We did so many times, right? Finding largest. Next, once we find out the largest, can we compare it with all the numbers in the array by going through the entire array? If this largest number, let's say we got the maximum. Okay. So what you have to check? You got the maximum. Now what you have to check, this maximum, is it greater than, or is it should not equal to, right? It is greater than. Is this greater than any other a of I into 2? If this is true for the entire array, if this is true for the entire array, then this is the actual largest. If this is not, then this is not the actual largest. Like if this is true, you have to print 1. And if it is not true, you have to print -1. That's what it is told. Oh, so if it is true, then you have to print index. Sorry, if it is true, you have to print index of this largest number, or which you can obviously find, right? If you find out the largest number, you already know the index, you can find out that index as well. If this is true for all the numbers, you have to print index. If it is not true, you print -1. Now, how will you check whether it is true for all the numbers? Iterate through the loop, write a loop, check whether it is true for all the numbers. Is this false for any number? Okay. Understood? Problem solved. Got it? Now, okay, last question on this addition subtraction. First advice is for those who are trying to convert it into numbers, don't. Okay, even if it's working, if there is no such test case which handling it, you should not be converting it into number. Okay, the addition should happen while these numbers are as arrays. Okay, while this number are stored in form of array. Now, how this addition actually happens? So you have to add two numbers. Let's say these are the two numbers which are each array index represents a digit. Now, what you have to do is you have to start from the end of the array and you have to find the sum. So 4 plus 1, 5, 3 plus 2, 5, 2 plus there is nothing, so 2, and then finally 1. So you have to find out this index and you have to store this into a result. Achha, now can you tell me what is the size of this result going to be? If let's say you are adding two numbers, so one is 2 digit, other is 4 digit, what is the size of the result? Depends on carry. Yes, that's the correct answer. So actually, the maximum size of this result can be 5 digits. Okay, how it is 5 digits? So let's say you're adding 99 and 9999. Okay, so in this case, the result is going to be 18, 99, 18, 19. So in this case, it is going to be 5. Otherwise, like if there is no such carry that spills over here, then it is going to be 4 digit. So the maximum size is 5 digit. Okay. How will we create a new array? Just take a new array. End result is equals to new end. What is the size? You got the size. Size is going to be the maximum between them. Whatever is the maximum size of array plus 1. Whatever maximum you get. So whatever is the maximum length, you create plus 1 length to it. Okay. You might get one leading 0 in the array that you can handle at the end, whether you have to have that leading 0 or not. If you want to remove it, you can remove it as well. But you have to initially create it of 5 size. Now keep on adding numbers, handle the carry scenario. Try to think ways of how you can handle a carry. So if there is carry, you just need to add 1 extra to the next addition. If there is no carry, then you don't need to add anything. Acha, tell me one thing. Let's say you find out this two sum. Take 9 plus 9, 18. So you got the sum of these two is 18. So what is the thing that you store in result and what is the thing that you take as carry? So you got sum as 18. So you can simply divide it by 10. So the division by 10 is going to give you 1. So this is your carry. you can simply percentage it by 10. This is going to, the percentage is going to give you 8. This is going to be the results. See, in the result array, in the result, you got 8 is the result, which is coming by 18 percentage 10. And whatever is your sum that divided by 10 is your carry. On the next iteration, you already have a carry, so you add 1 extra to it. Now keep on doing this again and again. For moving forward, if you finally have a carry, put it at the start. Try to do this. See, the question is easy, just that there is a little bit of edge cases that you have to handle, right? And that's what this question is there for, right? For you all to understand how this edge cases can be handled. Okay. Achha. Try to solve these questions, complete them. If possible, go to like start with array, like not possible, you should start with array 2s as well. Okay. Try to solve questions from here as well. I guess geometric triplet wala, I guess there is some issue of this in the test case. This was there in the previous one. I can't exactly recall. So if it is happening for everyone, we can skip for this for now. We'll verify it in the class tomorrow, right? Okay. And if you are done with all these questions and you have doubts, just you can jump to the gym section. There is tons of question on arrays. Now you are like on the place where you can solve more questions. Okay, we'll see more about arrays. There is still a lot of concepts to learn on arrays, like sub arrays. There is a lot of algorithms like Cadden algorithms. There is 2 pointers concept, right? We'll see sorting, we'll see searching on arrays, right? There is a lot of things that is there on arrays to be done in the class. We'll do that. We also have to learn about like little bit about memories of arrays. That is like still a little bit part of it is remaining. I completed almost like most of it. I covered 90% of it yesterday. So we still have a little bit of it remaining. So that will complete. Okay. 2D array will start. We have still 2 more classes on arrays, I guess. At least one we have. I recall at least there is one class before we start with 2D. Okay. And anyways, might have revisions as well. So that will use. Okay. Understood? Clear? Any more doubts? Any questions? Now, how do you remove element from the array? Actually, you cannot remove element from the array, right? So you need to create a new array with 1 less size if the first number is 0. What idea? If first number is 0, create an array of 1 less size, put all the numbers in it. Done. Anything else? Link. Okay, link to this code. Okay, I'll share it in the chat right away. Okay, understood. So try to just like do DSA now, right? Later, or you can get internships later as well. You can see learning will happen right now. Later, you can do internships and all those things you can do later as well, right? So try to focus on learnings for now. Internships, all those things will follow on. Okay. So, thank you, everyone. See you all again tomorrow. Bye-bye. Good night. Take care. Okay. Let's check it tomorrow. Okay. Thank you, everyone.